Okay, here we go. All right, I'm going to do the 4 problems that I promised I would do. First one we're going to do is 14. We're going to differentiate this, and this is a product rule. So we're going to make sure we label it as y prime. And so here are our 2 functions. So the derivative of the first one is going to be 12x squared times the arc sine of 8x. It's derivative of the first one times the second one plus 4x cubed times the derivative of the second one. Well, derivative of the arc sine is u prime, which is 8, over the square root of 1 minus u squared, which is 64x squared. Okay? So that's the derivative using a product rule on that one. Okay, so the next one we're going to do is number 15. And we've got an exponential times an arctan. So y prime, or dy dx. Okay, the derivative of this is 7 to the negative x power times the derivative of, times the natural log of 7, because it's an exponential, times negative 1, okay, times the arctan of 3x plus 7 to the negative x power, and then the derivative of the arctan is I'm going to get a 3 over 1 plus 9x squared. Okay, I'm going to clean that up. I'm actually going to go back up and clean up number 14. I want to point this out. When you distribute this negative, you cannot make this negative 7 to the negative x power. You can put a parenthesis around this and put a negative in front of it, but it is not negative 7 to the negative x. So, all right, so I'm going to clean this up a little bit. So I think it's easier just to put the natural log first. So I do negative natural log of 7. Then I don't have to deal with that at all. Times 7 to the negative x times the arc tan of 3x, and then it's plus 3 times 7 to the negative x. I cannot make that 21 because 3 is not part of that base, over 1 plus 9x squared. Okay, if I clean up the top one, the only thing I can really change is this. So this is really 12x squared arc sine of 8x, and then that numerator becomes 32x cubed over the square root of 1 minus 64x squared. Okay? All right, so the other one I was going to do is 17. I didn't do that one. Okay, so it's a product, and at the end of this one, we're going to factor it. So y prime, the derivative of 3x is just 3, and then it's x minus 5 to the 4th power. Okay? I don't think you want to multiply that one out. Okay, plus 3x. Then what's the derivative of this? Is I'm going to get a 4 times x minus 5 to the 3rd power times the derivative of that is just 1, which hopefully is obvious. All right, so now we're going to factor this. So 3 is common, and x minus 5 to the 3rd power, it's the lowest of the 2. Okay, and then what do I need to multiply this by? Well, I still have an x minus 5 to the 1st power. And then over here, I have a 4 and an x, and that's it. So this cleans up to be 3 times x minus 5 to the 3rd power times 5x minus 5, which, believe it or not, we can still factor out a 5 there. So this is fine, but ultimately, y prime is equal to 15 times x minus 5 to the 3rd power times x minus 1. Okay? All right, and the last one, number 19. We're differentiating again. So I'm just going to take care of the power the first time. So it's 4 cosine cubed of 8x. Now I got to differentiate the cosine, which is a negative sine of 8x. Really, times 8. So I'm going to put the negative there. Okay, because I still have to differentiate the function. Okay, on number 9, or on this one, I'm going to make this x to the negative 5th power. So then when I differentiate it, I get positive 35, and it's x to the negative 6th, which I'm going to put on the bottom, because remember, you reduce the power by 1. Okay, now we're going to differentiate the 10 to the x cubed power, which is, since it's exponential, is 10 to the x cubed times the derivative, or times the base, which is, so it's a natural log of 10, I guess it's not times the derivative of the base, it's times the natural log of the base, times 3x squared. Okay, the derivative of the arctan is going to, if that's u, so it's plus u prime, which is 10, over 1 plus u squared, which is 1 plus 100x squared. Okay, now we're going to differentiate the secant. Derivative of the secant is secant of 2x, is secant tangent, times 2, because still got to differentiate that argument. Okay? Plus, now we're going to differentiate this. This is really to the 1/2 power. So that's plus 1/2 times 1 minus 3x to the negative 1/2 power times 3. Okay, plus, the last one's going to be 3/4 times 10 minus x squared to the negative 1/4 power times 2x. Lower the power by 1, got to differentiate this. Okay, a little cleanup to do. It's going to be a little bit long, so I get negative 32 cosine cubed of 8x sine of 8x plus 35 over x to the 6th plus the 10 to the x cubed natural log of 10 times 3x squared. There's nothing I can really do with that. Plus 10 over 1 plus 100x squared. And then this is plus 2 secant of 2x tangent 2x. Okay, this one I'm really going to get 3 on the top, 2 on the bottom, and then this should go on the bottom. So it's really 3 over 2, and I'm going to write that as 1 minus 3x to the 1/2 power. And then our last one here, this becomes, what, 6 over 4, which is 3 over 2, so it's 3x over 2 times 10 minus x squared, I'm sorry, that's on the bottom, to the 1/4 power. Now there's no plus c here because it didn't do an antiderivative on any of these, because the antiderivatives were on the previous page. So hope this helps, and I will see you tomorrow, and good luck.